Okay, we're looking at the analytical solution. So the last video was the graphical solution to this problem. We're now going to look at the analytical solution. And we're going to put some of the skills that we've already learned to good use to do this. And this is why you're learning each of these skills. Now in a previous video, a previous lesson, we actually looked at how to resolve an inclined force into its component, horizontal and vertical components. Okay, so here's our opportunity to approach this multi-force system. We have three forces acting at one point, okay, all different values. Two of them are either horizontal or vertical, okay, but we've got one that's inclined. So what we're going to do is we're going to find its components, okay. So first we're going to do, well, let's do its horizontal forces first. So just so you know what force we're actually looking at, did I give you an angle? No, I didn't. This is 45 degrees. Okay, just like in the last problem. Okay, so we know that that's 45 degrees from the horizontal, and we know that it's 200 newtons. So we're looking at resolving that inclined force into its two components. Okay, pretty simple. So we go force horizontal is equal to 200, which is this force value here, multiplied by cos 45 degrees. So it's always cos theta, the angle of inclination of the force. Okay, so that's our force horizontal. And when we work that out, we'll get a value of plus 141.42 newtons, okay, horizontal, it's to the right because it's positive. You can see that if we were going to resolve this, if we draw a ray straight up and a ray across, okay, we know that that would be force horizontal and this would be force vertical. Okay, so we've done this type of problem before. We know that the components are both going to be positive because one's to the right and one's up. Because we talked about sign conventions. Up is positive, down is negative, to the right is positive, to the left is negative. Okay, just like your Cartesian diagram in mathematics. And then our force vertical is equal to 200 sine 45 degrees, and we end up with a force vertical of, let's have a look here, also 141.42. Straight up. So force horizontal equals that, force vertical equals that. Now, you might be saying, how do we get the same value? Well, I'm pretty sure that if you think about sine and cos graphs, the value of 45 degrees, sine 45 and cos 45 is the same. I should know this because I should know maths, but I'm not very good at maths. So if we go sine 45, it's 0.707, and cos 45 is also 0.707. That's why. Okay, so it's always good if you get an answer that's the same to think about why it's the same, in case you made a mistake. Okay, so we've got this inclined force resolved into horizontals and verticals, and the other two forces are horizontals and verticals. And now we can do our analytical solution. So you can draw a table, and in the table it's going to have three columns. Later on you might not have to set it out quite so pedantically, but hey, the more well set out your work is, the less likely you are to get lost in a question. First column is force, second column is force vertical, and I've done a sign with a plus to show it's up, it's positive. Force horizontal, to the right is 400 Newton force is vertical. So we can write it here, plus 400. But over here, we write 0 because it has no component that is horizontal. And then the next one is at 200 Newton. And we broke up our 200 Newton force into its two components over here. And they were both 141.42. 141.42. Let's put in newtons. 2. And then we had our 600 Newton. 600 Newton is horizontal, so force vertical 0. This is 600. And then at the bottom we just sum sigma is the sum. This is our answer from the last thing. It was 920. Okay, so we're just going to see how close we get. This will probably be more accurate. When we sum up the forces vertical, we get plus 541.42 newtons. When we sum up our horizontals, we get plus 741.42 newtons. Okay, all good so far. And then in our last example, when we looked at this idea of resolving forces that are inclined, we've got a force, sum of forces vertical, a sum of forces horizontal. So we get two forces acting at right angles. We're going to have a resultant. Okay, we've done this before. So we can draw a little diagram down here. We go 741.42 going across. We go up, tip to tail. This is 541.42 newtons. And then we need to find our resultant, force resultant. It should be something close to 920. And we need to find our angle theta. Okay, so remember how last time we did this idea as Pythagoras' theorem? So let's, I'll give ourselves a little bit more room over here, remembering that our purple answer is what we got last time. So we go resultant is equal to the square root of 741.42 squared plus 541.42 squared. Pythagoras' theorem, the square of the two sides, the sum of the square of the two sides, this side and this side, is equal to the square of the hypotenuse. Okay, God, I hope you know that one. And then we end up with a resultant. When you do the maths for this, the resultant is equal to 918.06 newtons. So fairly close to 920, okay? When you're talking about hundreds of newtons, your graphical solution was close enough, but obviously your analytical solution is 100% correct. And then we want to work out this angle, and we've done this before in a previous lesson. So, TOA, opposite on adjacent will give you the angle. So tan of theta, this angle here, is equal to 5 for the tan of 541.42 over 741.42, and that will give us an angle of 36.14 degrees. And that was 36 degrees for the original answer. Anyway, I'm running low on storage space on my computer, so I'm going to kill a few videos. Bye.